Hello everyone. Okay, so in this video we are looking at composite functions. So what is a composite function? So a composite function happens when you use the output of one function as the input for another function. So it's like putting one function inside of another one to create a new function. So a composite function could be written like this: f of g x, f of g x, or sorry, f after g x. So we apply function g first, then we apply function f, or we can write that as f big bracket g of x, or we can write that as fg of x. It's really important we work from the inside out. So we do function g first, then we do function f. So this reads as f after g. Something to note about composite functions, right? F after g of x and g after f of x, they're not interchangeable, right? F of g of x is not always equal to g of f of x. So let's look at a very, very simple example to explain this, right? So let's look at a washing machine and then let's look at a dryer. So here's my washing machine, here's my dryer. So what happens is clothes, here's my pants, they go into the washing machine. This is my function f. They go into the washing machine, they come out wet. I put them in the dryer, my clothes come out dry, right? And my dryer is function g. So if I apply f first and put them in the washing machine, it washes them, they come out wet, then I put them in the dryer, they come out dry. But what about if I swap the order? Right? If I swap the order, this is my washing machine, sorry, this is my dryer. And this is my washing machine. So my pants go in, they come out dry. Well, drier, they go into dryer. Then if I put them in the washing machine, they come out wet. Do you see how I have now two different kind of outputs for what's happening? If I put my jeans in the washing machine, they put them in the dryer, they come out dry and clean. If I put them in the dryer, then they come out. Then I put them in the washing machine, they're gonna come out wet. So here I applied function g first, then I applied function f. So they're not interchangeable with each other, and that's very important to note and never assume. So let's look at some problems here. Consider the function f of x equals 2x plus 3, g of x equals x squared. Solve the following. So what is f of g of x? So f of g of x is equal to f of, and my input is g of x, which is x squared. Now my input for my function f is x squared, so it's going to be 2 times x squared plus 3. So f of g of x is equal to 2x squared plus 3. G f of x is going to be equal to g of f of x, which is equal to g of 2x plus 3, which is equal to, my input now for function g is 2x plus 3. My function is x squared, so that's going to be 2x plus 3 squared, which is equal to 4x squared plus 12x plus 9 when I multiply it out. Right? I ask you, say, what is f of g of k plus 2? So wherever I have a k plus 2 in my function f of g of x, I put in k plus 2. So my function of f of g of x is 2x squared plus 3. That is going to be 2 times k plus 2 squared plus 3, which is 2 times k squared plus 4k plus 4 plus 3, 2k squared plus 8k. 2 times 4 is 8. 8 plus 3 is 11. When g f of x is equal to 0, so when this is equal to 0, so 4x squared plus 12x plus 9 equals 0. 2x plus 3 squared equals 0. So this is factored form. Square both sides. 2x plus 3 is equal to 0. X is equal to minus 3 over 2. When f of g of x is equal to 11. F of g of x is equal to 11, so 2x squared plus 3 is equal to 11. 2x squared is equal to 11 minus 3, which is 8. X squared, which is equal to 8 divided by 2, which is 4. X is going to be equal to plus or minus 2. Finally, the last one here. We want to find the value for x for which f of g of x and g of f of x are equal. So 2x squared plus 3 equals 4x squared plus 12x plus 9. Bring everything over to one side. I get 0 is equal to 2x squared plus 12x plus 6. I can divide across by 2 to make it easier. I'm going to get x squared plus 6x plus 3. So I'm going to have to use my minus b formula here. So minus 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 1 times 3, all over 2 times 1, which is equal to minus 6 plus or minus 36 minus 12 is root 24. Root 24 can be written as 2 root 6 all over 2. Therefore, my final answer is going to be minus 6 divided by 2 is minus 3. Plus or minus 2 root 6 divided by 2 is root 6. There is my answer to that one. And that is as hard as composite function would get. Let's look at some exam questions here. This is from Leaving Cert Higher Level. So, h of x is equal to x squared plus bx minus 12. Find the value for b for which x minus 4 is a factor. So x minus 4 is a factor. So if x minus 4 is a factor, that means x equals 4 is a root. So if I sub that in, this should equal 12. So 4 squared plus b times 4 minus 12 equals 0. 16 plus 4b minus 12 equals 0. 4b is going to be equal to minus 4. B is going to be equal to minus 1. Stunning. Fine. This one here, the function f of x and g of x are defined as follows. So if you're in ordinary level, leaving cert, you just skip ahead a little bit because this question is dealing with logs and exponentials, which you don't have to do. So f of g of x defined as follows. F of x equals e to the power of 9x. G of x equals ln root x. Find the value of f of 1.2. So f of 1.2 is equal to e to the power of 9 times 1.2. Write it in scientific notation. E to the power 9 times 1.2 is equal to 49020.80114. But I want to write this in scientific notation to one decimal place. So it's going to be 4.9. So 1, 2, 3, 4. Move the decimal place over 4, multiply by 10 to the power of 4. That's that there. Find the value of x when g of x is equal to 3.5. So g of x, ln root x. So I want to find the answer for x. So ln root x is equal to 3.5. So BAP, L of n, right, is actually log base e. So what I could just do is I can just do root x is equal to e to the power of 3.5. Then square both sides to get rid of my x, get rid of my square root. So x is equal to power by power we multiply, so 3.5 times 2 is e to the power of 7. There's my answer there. And finally, write the function g of f of x in its simplest form. And that is going to be, so g of e to the power of 9x, which is going to be equal to ln root e to the 9, e to the 9x. E to the 9x. That's going to be equal to ln of e 9x to the power of a half. Ln of e to the power of 9x to the power of a half is 3.5x. Then I now have log base e, which is what ln is, of e to the power of 3.5x. Using my rules of logs, I can bring this down in front by any powers. So 3.5x log e of e, which is equal to 3.5x, because log base e of e is equal to 1. So g of f of x is actually equal to 3.5x. Right, let's just look at some more examples here. This is from the 2020 Leaving Cert Higher Level. Investigate the following. F of g of x is equal to g of f of x. Let's see if that's true. That is going to be equal to f of x plus 5 over 6 and g of 6x minus 5. So that is going to be, so f of 6 times x plus 5 all over 6 minus 5. 6 is going to cancel here. X plus 5 minus 5 is equal to x. Here, g of 6x minus 5, that is going to be equal to 6x plus 5, sorry, 6x minus 5 plus 5 all over 6. Top is going to be 6x all over 6, which is equal to x. Therefore, they are equal. Right, let's just look at this one here. This is from a GHR high level paper many years ago. Verify that g of x is defined as 9 minus x squared. Verify g of 4 is greater than g of 2. So we're applying function g twice. So g of 4 is going to be 9 minus 4 squared, which is equal to minus 7. Then g of 2, so that's g of 2, which is equal to g of 9 minus 4, which is g of 5. And minus 7 is greater than 9 minus 5 squared is minus 16. That is true, right? And that's it for all this video. And I'll catch you guys later. Bye. Ready to